going here. All right. So you guys watched the video yesterday on polynomials, right?
Yeah.
Y'all feeling like inspired? So we're going to take some notes so that you have it for next year and years to come. And then we're going to talk about adding and subtracting polynomials. And that will be our day. Okay? So the first thing we're going to do is some vocabulary. So we have monomials. And then we have binomials. And we have trinomials. Anybody remember from the video what a monomial is?
It's
one term, right? And it might look something like 3x, right? How about a binomial? Two terms. And it might look something like 3x plus 7. Remember in the video they talked about that if you can't understand why there's not an x with this one, that could be x to the 0, so that would just be 7 times 1.
Does that mean that 1 plus 1 could technically just be a binomial if it's just 1 plus 1 times x to the 0 plus?
I guess, yeah. And then trinomials are 3 terms, right? And this is where we might get some x squareds in here. So maybe we have 8x squared plus 3x plus 7. And so binomials and trinomials can also be considered polynomials, which is usually what you'll hear. You won't hear people often say binomial or trinomial, but I still need you to know the language. And this is just 2 or more terms. So it could be 2, 3, 4, 12, right? Hopefully this all sounds vaguely familiar.
Yeah.
A little bit. It's just one term. Yeah, it's just hanging out by itself.
Single number.
Okay, so then our next vocabulary is the degree of Yep.
I did that too.
What did you do?
I drew a big old line.
Oh no. Rookie mistake. The book's coming out. I just want to make sure I'm not mixing words here. Okay, so the degree,
Oh yeah. Yeah. No,
The only one you had?
no, it was Crystal Bay versus Thunder Bay dance off.
Let's-
I did the split. And
let's change this into monomials, degree of monomials.
I remember that, Anthony. You just brought back a big one. And it was
did you win this splits?
That dance was terrible.
They
And
just
that
went
shit.
home. They just so and then you did the splits and they were like twins. Wait, you you like actually did the splits?
Yeah.
Yes.
How?
You know how to do the splits, or did you like?
No, he did this like sit dance and then he was like ice.
Can you do them right now? Let's with jazz hands.
Do it.
Do the default.
Do
dance
backflip
and do the splits.
That would hurt so much.
Okay. So I changed that to monomials because we need to talk about each individual term before we can go on to polynomials. That's what I wanted to double check. Okay, so we're talking about the sum of the exponents of the variables in an individual term. So an example, we'll do some examples.
Is this still vocab?
Still vocab.
Yes.
If I have 3x here, what's my exponent with that 3x?
First two. 0.
Oh, 1.
Oh.
So that's going to be, the degree is 1, right? Because there's one exponent hiding right here. If I'm adding up all the exponents, I'm just going to have a 1. If I have something like this, what would my degree be for 4ab squared?
2, not 3.
3, right? Because there's that secret 1 right here. 1 plus 2 is 3. What if I have something like this?
0.
0. Yes, my degree is going to be 0 because remember there's that x to the 0 power. That's what they talked about in the video. Okay, so the reason we had to talk about this first is so that you can find the degree per term, right? So then the degree of polynomials is the greatest degree of all terms. So that sounds a little cryptic.
It's the GDAT.
Okay, so if I give you this example, if we have 2x to the third, x squared minus 5, x to the third plus x squared minus 5x plus 12. I have a lot of terms here. I'm going to move that 3 because it's kind of hanging out by itself. There we go. Which one has the greatest degree? Which term has the highest degree? This one right here, right? So for my answer here, it's just going to be 3. I'm not going to add all those up. My degree of this polynomial is going to be 3. So you find which one has the highest exponent value, and that becomes your degree.
And don't you do like in order too?
We are going to talk about how you put them in order. Yes. So another example. What would be my degree here? 4. How are we feeling? Good?
I'm good.
Okay, let's move on to adding polynomials. Next page. So we just had our vocab. Now we're going to talk about adding polynomials.
Wait, so now can I go on? I'm doing it. I'm going for it, guys. Do it.
Don't do it.
But it's still pretty good. Would you have a razor?
No, no, my pencil.
Ah, there is turning. But still, don't do it.
Do it.
Can't believe this.
I can't either.
the tragedy of 2020.
She drew a line.
She drew a line and caused a series
The
of
line separated the entire earth in half.
Okay, so adding polynomials isn't that difficult. If you can add and subtract, you can add polynomials. The only thing you have to pay attention to is the degree of each term. You cannot combine terms that have different degrees, meaning you can't combine 3x squared plus 4x to the third. You can't combine those. They have to have the same variable and the same exponent. Okay, so let's just jump right into this. Oh, sorry, change this. Okay, so we have these beautiful polynomials, two trinomials. Okay, so when I'm combining these, I have to pay really close attention to the exponent, right? So because these both have x to the third here, I can combine them. So what's 2 plus 2? 4. Now I can combine negative 5x squared and positive x squared. So how many x squareds do I have? Negative 4x squared. Then I have a random x and a negative 1. Those are just going to stay the way they are because I don't have an x value over here to combine that with, and I don't have a constant value over here to combine this one with. So then I'm going to have plus x minus 1. And that would be my answer.
Can you simplify?
Can't do anything with that. All we're doing is adding polynomials. We're just combining them. We're looking for pairs. Would color coding help? You guys want to do some color coding?
No.
No colors?
No colors.
Would it help if just I did the color coding so you could see it?
Yes, sure.
Oh, yeah. Only with the sniffy.
Yeah, do the
No,
sniffy
you
one.
won't be able to see anything then. That's why we use colored pencils.
Oh, the sniffy one.
I'm not using the
You can
Mr.
smell
Sketch
the pure
markers.
math.
But
Come
we'll
on.
use some fun spring colors here.
No, we need to smell that.
You need to be able to smell the math happening.
Oh, this is a fun color.
I don't know color.
Okay.
I want scent.
So
It's all like chocolate.
I can combine this number and this number for here because they all have x to the
I
third,
don't smell it.
right? I can combine negative 5x squared and positive x squared because they both have x squared. This doesn't have anything over here that matches, so this just comes down by itself. Oh, I think I need a different paint. Let's do
Green.
green. Oh, this is a fun color. Oh, I don't know, that might look like that one. Hold on. Yeah, this is a fun one. And then this one is by itself, and so it's by itself down here. Yeah? You see it now?
I see it.
Did that help?
It's all coming together.
I can't smell it, so I don't know.
Okay. All right, let's do another example. 4n squared plus 5 plus 5n to the third minus 7n squared plus 6n.
Oh.
Don't pretend you know. Don't pretend you know it.
No, I do know.
And he's like, there's no way you aced that test.
I know he was like, I just can't remember his name. Mrs. Marsh,
Yes?
what do you think is not the same letter?
Then you can't combine them either. Right. They have to just kind of hang out, and you'd put them in order by degree. So if I had like 6n squared and 7m squared, I would put those next to each other, but you can't combine n's and m's. Yeah. Okay, so let's color code again. I have a 5n to the third over here. Do I have anything over here that has n to the third?
No.
No.
Nope, so that's going to be my first term.
So you only add them together if they're both like variable to the same.
Variable and exponent are the same. That's the only time you can add them together. You can combine them. Okay, and then my next one is 4n squared and negative 7n squared. So now I've got negative 3n squared. And then I've got 6n over here, but I don't have any just plain n's over there, so I'm going to add my 6n.
What about the 5?
And then the 5 is also hanging out by itself. So it's just going to come down here like this.
That's been fun.
God, I hate how they added like stuff like letters in the math, because now when I like have a plus symbol, I keep thinking it's a
So there's my answer. How do you guys feel about adding polynomials?
Okay. It's fine.
Not terrible, right? There could be worse things.
Like subtracting polynomials.
Like subtracting polynomials.
No.
Parker's on it.
Your idea.
Okay.
No, what?
So
Oh my lord.
Parker.
let's talk about subtracting
You
polynomials.
know, the worst thing would be graphing them.
No, don't talk.
Stop giving her.
I did. I'm gonna give her more. That's no fun.
You guys are going to love all things polynomials, trust me.
I'm going to
The
decide.
best is when you get to factor polynomials. Yes. When you're given this and you have to create, so like factoring polynomials, just a little glimpse into your future, is when I might give you this, and your job is to create these two quantities.
Exactly.
What?
How
No,
far,
that's
how
not
exactly are we supposed to do that?
I mean, it's a couple weeks. You guys are going to do great. You're going to do
Like,
great.
we're talking after the spring break or before break?
Well, let me see here. So we've got multiplying,
Do you have
introduction to factoring, factoring fun. These are all my titles of my notes. There's a lot of factoring. Probably you'll have at least a short quiz before you go on spring break.
No.
Yeah.
Come on.
Yeah. Listen, you guys are gonna be so proud of yourselves. It's so fun.
Either that or we're gonna feel even
No,
worse.
the thing is that you have to end the unit before break or else we'll
I
like.
don't have
I
to.
know, but then
You
we'll
should.
forget
It's
it all.
polite. It's the polite.
It's the right thing to do.
Because then if you have it just afterwards, we
Treat
should
other people how you want to be.
Yeah.
Okay.
Yeah, you want us to give you a
Avery.
quiz before.
Okay. Let's get back. Remember, we're making a video here. Okay.
Oh,
So subtracting polynomials it's really not that bad. There's just one extra step. That's it. Okay? There's just one extra step. So let's do our examples. Oops, let me write the word examples. Got to stay true to our format here. 4x squared
Yeah, then how's that big line working out for you?
minus
Actually
3x
pretty well. Look how nice and neat it looks.
plus 5.
Oh,
So
wow.
go ahead and write this down. And then I want you guys to pay really close attention. I'm going to put my subtraction sign, and then I'm going to leave a little space. Do you guys see how I left a space there? Leave the space there, and then write your next polynomial.
You. Oh wait, leave space.
Yep, leave a little space there. Okay. So again, we have two polynomials. We're going to be combining terms based on the addition or subtraction. But the little step we have to do first is what's hiding here between this negative and this parentheses? A 1. So what you have to do first is distribute this negative 1 to this polynomial. So now what you're going to have is 4x squared minus 3x plus 5 plus negative 3x squared plus x plus 8. So you're basically changing it from a subtraction problem into what we were doing with adding, but before you can do that is you have to distribute that negative 1. Oh. And now we're right back. We're right back where we were. You just have this little extra distributing situation here. That's really it. So we've got our
Okay, you know what? I'll take that. Don't
4x squared and negative 3x squared. So how many x squareds do we have?
1.
So we just have x squared. Or you could write 1x squared if you wanted. It's up to you. Then we've got negative 3x squared, positive 1x squared. So what are we left with?
2x.
Negative 2x. And then we've got, what's our last one, green? 5 plus 8. So we get positive 13. See? And then we have our answer. We subtracted our polynomial. Yay!
I'm not very pleased.
You're good. You're good. Okay. Let's do another example.
Are you guys like okay in the head? Wait. You thought we were okay in the head, and you aren't. Good point.
Go ahead and copy that down. Leave that little space there.
How do you have more space
I have more
I
space.
followed every line that you did, like every space. And
Well,
how
I
many-
use college ruled paper,
Oh.
so I get more lines.
This whole year. on
I
how
did
you
it
have more space.
I was able to.
I'm glad you finally felt comfortable enough to ask.
Technically, it's still possible
Well,
to,
that's
even with
awesome.
wide rules
Like that.
lines, to get more out of our paper than you. If you use a large
Well, I
margin,
like when you are
Yeah, that's true.
I usually just squeeze the stuff.
Okay, so what do I have to do here before I can combine these polynomials?
Distribute the negative 1.
Distribute the negative 1. I'm going to draw my little arrows for my organizational purposes. So I'm going to end up with 4m squared minus m plus 2 plus 3m squared minus 10m minus 4.
It's not difficult, it just hurts
Do you guys want to do this on your own?
Sure.
Okay, I'm going to freeze the screen. Those of you watching the video, of course, can see what I'm doing because I can't freeze that screen.
Can I watch this live?
I'm sorry?
Yeah.
We're being recorded.
Well,
You live stream this class.
so what I have done in the past for students that are quarantined or out for whatever reason, they can Google Meet with me and they can see this and we can chat.
There's
Also, do we get our test back?
You do not. It has been kind of a hectic week, so I will have them for you next week. I apologize. Okay, who's feeling confident? Caleb, let's hear it.
Okay, so 7m squared minus 11m. No, that's wrong. Minus 9m, sorry.
What?
No.
Minus
Minus
11. It's minus 11. Ah, I'm everywhere. Minus 11 and then minus 2.
Yay!
Fantastic.
Yeah, minus 2. Have fun.
Okay,
I had it wrote down.
so we have one more thing for our notes today, and then we'll be done. One more little skill here. Oh, Mrs. Marsh.
No.
Okay.
We need an entirely new piece of paper for this.
Fractions, I'm walking out of the classroom.
There's no fractions.
If there's even decimals, I'm leaving.
If there's no
Aren't decimals just worse than fractions?
No, decimals are better, but still, it's not.
fractions are actually much worse than decimals.
Exactly.
I like decimals better.
Okay, we're going to practice writing polynomials in standard form.
You're not welcome here. Rude.
I think today's having trouble making up its mind about the weather. It's been cloudy, it's been rainy, it's been windy,
In the
sunny, cloudy, rainy,
Windy.
sunny.
Snowy.
It's like
cloudy. Rainy.
It's like all the things in one day.
Yeah.
Yes.
We're just waiting for a flood
I have the so
and a fire.
pepperoni pizza. And then my mom.
Okay, Caleb raised his hand. What do you have to say, Caleb?
If we're gonna do like the afternoon outside thing,
Mhm.
like, what if like the day we planned it, it like rained?
Oh well, then we're not gonna do it ever. Of course we'll make sure you get your afternoon outside.
I thought you
Yeah.
Okay.
maybe you, doesn't it, Caleb?
Well, I thought you were just
And
gonna
then
be like,
I'll
well, then we'll go watch
Wait,
the movie.
you would, and then if that happens,
No. No, we've had several students request. What if I would prefer to watch the movie? So we're gonna figure it out so you have a choice.
No, we should get a projector outside with like a big screen and a projector on the wall.
No, we should get like ponchos.
Okay, what we're gonna do now is finish the notes so I can finish the video.
Watch a movie all at the same time.
Okay,
Play football.
writing polynomials in standard form.
Ready?
Okay, so there's a rule. You must order the terms. Oops, that's not good. That's not good grammar. The terms from greatest to least degree. Right? Remember that degree is the exponent. So if I gave you this polynomial here, this trinomial, clearly it's not following the rule. So I would have to rewrite this. The trick is to keep the addition or subtraction symbol with the term accurately. Okay, so what would be my correct order for this polynomial?
7x.
-9x plus 8.
No, because it's greatest to least degree, so we go
We're
by
looking at the
7x,
exponent value.
x,
I
8
thought
to the
it
x.
was. I thought it was least to greatest.
Oh wait, no, it's greatest to least, yes. I'm like, did I write that wrong? 7x to the 8th
Plus 6x to the 4th.
minus 9x to the 3rd.
Third.
I was right.
So we have to rearrange, paying really close attention to the symbols that go, like the addition or subtraction symbols.
Your arrow kind of looks 3D because it gets smaller and bigger.
I'm sorry?
Your arrow looks 3D.
Oh. Must just be the way I put the lead.
Oh wait, whoa.
Oh, you said arrow. I thought you said air.
That's not her air looks 3D. Well, isn't it?
I was like, how do you spell it?
No.
No. I was like, do
It's
you have
not
a
her
superpower?
The air feels
I vote
3D.
vote.
Are you seeing it?
Air's 4D actually.
Air is in the
I don't
That's
believe
not
in
how that works.
Yes, it is.
I'm fairly certain it's not.
Stop.
Okay. So what will
They're
my
wrong.
correctly written polynomial be? Lily.
-4x to the 3rd plus 2x to the 2nd plus 5x.
Perfect.
Good job.
Very nice.
That's my first time getting it.
Wow.
And after
Questions, comments, concerns?
One will.
Okay, that is our notes for today. I'm going to go ahead and stop the video.